thank you very much for choosing to join my talk on Eclipse Graphene and building AI pipelines with it. So it is a new project. It is in incubation phase, and to give you a short history of how this Eclipse project came to be is that in March 2018, the project Acumos AI was started at the Linux Foundation. And then in 2019, there was a project called AI for EU that is funded by the European Commission with a target to build the European AI on-demand platform. And AI for EU decided to build the experimentation subsystem using Acumos AI. And this is where I'm mostly involved. So I'm the lead architect of AI for experiments. And in beginning of 2020, the very first AI for experiments installation based on Acumos AI was publicly available. And in the first half of 2021, the main sponsor, AT&T, basically stopped funding Acumos AI, and the Linux Foundation decided to stop and archive this project. And AI for EU, being a European project, decided to start a fork of Acumos AI, which is now Eclipse Graphene, because Eclipse Foundation was moving to be a European organization at that time. But there are many fundamental differences between the original Acumos AI project and now Eclipse Graphene. And we are now in the process of making the first initial release. So it's quite, I think we have more than a dozen repositories. And so the process of making this initial release takes some time. And here's a short system overview. So we have, on the left-hand side, we have the Graphene portal, which contains the catalog and the design studio and the deployment services. And it is important that by design and intentionally, it never stores any big binary data. So we don't store any Docker images and we don't store any data sets. They are only referenced. That has important advantages when it comes to intellectual property, but also regarding security and keeping all the things up to date. So we leave it up to the module providers to keep them up to date and to host them. And then we have a system border. This is the big black line. And to execute pipelines and modules, they have to be deployed to execution environments. And there can be many different execution environments. Currently, it is based on Kubernetes, but it could also be Kubeflow or maybe Apache Airflow. That's possible. That is flexible, built into the architecture. So, but this is a very important separation between the portal and the execution environments. It has also the big advantage if you want to process confidential data. You bring the pipeline to the data, for example, into your company IT, where you have full control over the data and over the pipeline. So this is why we have, from the beginning on, we have this mechanism of supporting many different execution environments. It's also possible to deploy to a laptop or to deploy to HPC. So the very first important part of Eclipse Graphene is, of course, the marketplace. The idea is to have reusable AI modules, and it is possible to work in teams, and we support commercial and open source licenses for models. So there's a big difference. The difference here is Eclipse Graphene is completely open source, but for the contents, so for the modules that are onboarded into Graphene, into an instance of Eclipse Graphene, those can be commercial or open source. Both is supported. And here are some examples of AI pipelines that can be composed in the design studio. So we have here on the top, we have a training pipeline, which uses, for example, a TensorBoard node and a shared folder for common data storage. The design studio also shows matching models to make it easier for a user to find the right connection, to know what modules can be connected together. And we have also application pipelines. Here the example on the lower half is an audio pipeline, which consists of a lot of nodes, so it's one of the bigger pipelines. And the idea here is, for example, a user could easily switch out the German speech-to-text with English speech-to-text. So this can be done even by non-AI experts, just by domain users. That's one of the ideas. Then, as an example for an execution environment, a part of Eclipse Graphene is also the AI playground. It enables one-click deployment. I will demonstrate it after the presentation. And it is based on Kubernetes. So what you see here is the different nodes that are listed in the screenshot. And it's basically a UI over Kubernetes commands. So very important is the container specification for the reusable AI modules. And it is based on Docker, of course, but with additional properties. So it is expected that the public interface of this AI module is exposed as protobuf gRPC interface. So it is defined in protobuf, and the communication protocol is gRPC. It's completely open source. And it is recommended also to provide a web UI for this module so that the user can interact with this node. This is optional, but highly recommended. We have made very good experience with nodes that expose this web UI also. So, and this is not a lock-in. So the module, even if it has these additional properties, it's still a normal Docker container that can be run in any environment that can run Docker containers. And if done right, the same Docker container can be used across different execution environments. So it can scale from laptops to big Kubernetes clusters. For example, PyTorch and TensorFlow, they are able to detect if a GPU is available and use it, if so, and don't use it if it's not available. So if a container is built in this way, it is really possible to have the same Docker container to be used in different execution environments. Then what we also developed is our Graphene orchestrator. And the orchestrator is the responsible part in the execution environment that passes the messages according to the topology. So it looks at the nodes and the edges of the topology and then starts passing the messages according to the topology. And thanks to gRPC protobuf, we are able to generate all the communication artifacts on the fly. So this is why the orchestrator is able to communicate with modules it has never seen before. So it's really dynamic. And we also support gRPC streaming. That means we are able to support asynchronous communications like sensor input or user input, media streams, and the edges can be served in parallel. This is one possible implementation of an orchestrator, and there are different orchestrator implementations possible. So this is the only part, I would say, that of graphene that runs into an execution environment. So the pipeline definition is intentionally technology neutral. So it's a simple JSON file which contains the nodes and the edges, and it is generated by the design studio, but it can also be generated elsewhere. It is possible to think about generating a follow-up topology after a pipeline run to try out another topology for improved results. So it's for AutoML, for example. This could be possible, or you can import the pipeline definition from another system, maybe from OpenML or from Hugging Face. That's also possible. So during then taking the technology neutral pipeline definition, the JSON file, the deployment for a specific execution environment generates all the necessary artifacts. So for example, to deploy a pipeline into Kubernetes, it looks at the nodes and the edges and creates the necessary deployment YAMLs and service YAMLs, and the persistent volume if there is a shared folder. So that's the idea, to generate the specific configurations from the technology neutral pipeline definition. And as I said already, different orchestrators are possible. Currently we have only one, and we have the shared folder support. This is also depicted in the screenshot below. So the node on the left, REST server out, is the path where all the nodes can store and access files. Then we have also the notion of a data broker. The data broker has the special function of being the very first node of a pipeline. So it has usually no input message, only output messages, because it's the first node. And a data broker is usually a shallow component that makes data available to the pipeline. So it does not contain the whole data set. It only makes it accessible. So, for example, it knows credentials to access a database and is usually specific to an execution environment. So if you want to execute in your company IT a pipeline, you probably have to write this small data broker which enables the data to be fed into the pipeline. And we have already also a prototype for a sister project, Eclipse Data Space Connector, to access data that is provided by international data spaces. So what do we have on our roadmap? So as I said, we are just starting this graphene project, and so we want to support recursive data structures. So it's how we process the protobuf definitions and message definitions. Then we are working on a concept called Jupyter Connect. So it is then possible with one click to deploy a model along with a pre-configured Jupyter Lab node, so that you can directly explorative use this node. You can try it out, basically. You deploy it to an execution environment and can interactively work with it. Then support for benchmarking and also reproducibility. We are working on hybrid AI pipelines to combine sub-symbolic and symbolic AI components, deployment to high-performance computing, and in the midterm future, we are also thinking about ways to support AutoML on a pipeline level. So what are potential graphene use cases that we've seen so far? So generally, it's building AI pipelines from reusable AI modules. Then for researchers, you can use it for model training, for benchmarking, and for interactive computing using Jupyter Connect. For education, it could be used for practical live demonstration in a lecture or for student exercises in the playground. To support ML ops, so to simplify deployment, as I said, we have one-click deployment to an execution environment to our playground. This can be done for training pipelines, for data cleaning pipelines, and it can support many different ML ops tools like Kubeflow or MLflow or DVC or Pachyderm. Then we have, you can use it as a model showcase or internal or external catalog if you want to see how many modules your company is really using and has available. And on the application level, it is also thinkable that to let non-AI experts compose and deploy pipelines for the business domains, as I have shown with the audio pipeline. So we have one customer who is using audio mining, and so it is possible for them to create the pipelines as they need it. They don't have to contact a developer. It is also possible to do collaboration, so to work in mixed teams for knowledge transfer. So if there is a small company who wants to start using AI, it's possible to work with external experts to create a proof of concept, for example. And it can also be used for automated certification. So those are the main use cases. And I've also collected here in the slides some useful links. So the main system, the main installation of Eclipse Graphene is currently AI for your experiments. And there are also the links to the Graphene project and the GitLab, the container specification, and we have quite a lot of tutorials that show how to create those modular AI components. So now I want to demonstrate. So this is the AI for Experiments installation that has been built up in the course of the AI for You project. It is continued in more follow-up projects. So currently, the current running main project is called AI for Europe. And what you see here is the marketplace, the component, the catalog. And if we look, for example, at one of the components, then we have a description for it. There is a license profile. Sorry. It can be, this is Apache 2 license, but can also be a commercial license. And here is very important the signature. This is the protobuf definition of the public interface. So this must also be onboarded onto the system so that the design studio later on can use it to do a model and port mapping for the communications. Then documents can be uploaded, the model artifacts that are generated. For example, here is the Docker image tag where you can that you could use for a Docker pull command, which is also used when it is deployed. And there are also author and publisher details. Then let's have a look at the design studio. So let's say we want to create an audio pipeline. Then we maybe start with audio segmentation. And now I want to see what can I connect. So here in the right top corner, there is the panel for matching models, and now I can see what other modules match this interface. So audio segmentation, maybe I would now want to use speech-to-text English. So I drag it to the canvas, and then it's a match. So in this way, I can connect my pipeline. Maybe in this way, in the other direction, I have to start with a data broker. The first node in the pipeline should always be a data broker. So in that way, I can construct my pipelines. That's the way it works. Now let's have a look at one of the existing pipelines. So the Sudoku tutorial stream. No, I don't want to save. So it uses even a simple circular topology. This is also supported by the orchestrator. And I can now deploy it for execution with one click. So we use the KI Lab playground. So it takes a little time. And this playground is publicly available. It has limited and is freely available, but it has limited computing power. So let's have a look. We have 3 nodes in our pipeline, and we see in the playground there are 4 nodes deployed, and the additional node is the orchestrator. So this is automatically added to the deployment. And now I have to actually start the pipeline. So now the orchestrator makes the connections to all of the nodes and waits for messages. And then I connect to the web UI. So as I said, each module has 2 ports, one for gRPC and one for an optional web UI. And here I can now connect to the web UI for Sudoku. And now I can enter here some digits. And as you see, the solver responds immediately. So it makes proposals how it can be solved. Of course, if I input just one number, it's not enough. So if I add more numbers, there are fewer possibilities. And if I make a mistake, for example, I add a second 5 here in this row, then the solver tells me the Sudoku has no solution. So this was the one pipeline, and I also want to show the training pipeline. The news training pipeline. This pipeline uses a shared folder, and the model that needs to be trained is the news classifier, and it is controlled by the news trainer, and the TensorBoard node is just added. It's reusable, and it will look at the logs that are written to the shared folder. So let's deploy this with one click to the KI Lab playground. So it sometimes takes a little time for all the Docker containers to be ready. Okay, now all containers are ready. So here I can, for example, look in the shared folder, and I see there is already the training data available. And if I start now the training, so this is really a simple model. It shouldn't take too long. Now we can have a look again at the shared folder. There I can see The trained model is saved also. I can download it here. I can get my trained model. And here are the log files. So I can also now connect to the news trainer. Here's an example for the web UI. So here I could set some training parameters that I can change for the training run. So if I want to make a new training run, I could change the number of epochs or the batch size or some other parameters. And there is also, I can now have a look at the tensor board, which shows me some diagnostics. Time series. So that was basically my presentation. Thank you very much for attending, and if you have any questions, then I'm happy to answer them.
Question?
Yes, please.
How do you go about investigating problems in the chain, debugging?
Oh yes, a very good question about how to debug. So there is, we have the logs. So you can have a look at the logs of the container. So that's basically, if you issue a kubectl command, kubectl log, this is the output. So this is one, and there's also, we show the status details of each node. If there's something wrong with pulling the image or something like this. Any other questions? That doesn't seem to be the case. Then thanks again for attending and see you around. Bye.